Hey everyone, today we are going to be talking about solving rational equations. Um, there are some reasons behind that. You're more than welcome to read some real world examples down below. So our first problem, this is what it looks like. 3x over 4 equals 5x plus 1 over 4. How would you solve this? Well, what this is called right now is a proportion. Whenever you have one fraction equal to another fraction, it is called a proportion. And when it's in this form, we can cross multiply. You should remember that from geometry. So we're going to cross multiply. Okay, but remember that's only when one fraction equals another fraction. That's the only time you can cross multiply. Okay, so after you've done that, all right, you're going to simplify. And so that might mean combining like terms or distributing, all that good stuff. Then you're going to solve for your variable, and then you're going to want to check. Okay, so let's go ahead and do that first problem. So we're going to cross multiply. So remember, you're multiplying what's on the diagonal. So you've got 3x times 4, and we know that is 12x. And now we're going to multiply 4 times 5x plus 1. You might want to write that down, just like I am, so that I can remember I have to distribute my 4. That's where most people get into the most difficulty. All right, so I get 20x plus 4. Now I'm going to solve for x. I'm going to subtract 20x from both sides next. That's going to get me negative 8x equals 4. Final step, divide by negative 8. 4 over negative 8 reduces to negative 1/2. Okay, now let's do a check. Make sure that it worked out for ourselves. So 3 times negative 1/2 over 4 should equal 5 times negative 1/2 plus 1 over 4. So I get negative 3/2 over 4. I'm going to leave that as is. I'm going to have negative 5/2 plus 1 over 4, but 1 is the same as 2/2. So negative 5/2 plus 2/2 is negative 3/2. So we did get the same thing. Good to go. Our final answer, x equals negative 1/2. Here's another one. Feel free to do it on your own and stop the video and press play whenever you're ready. So again, it's a proportion, so we're just going to cross multiply. So we're going to get 2x minus 3 times 6 equals 2x minus 5 times 4. So we distribute our 6 to get 12x minus 18. We distribute our 4 to get 8x minus 20. I'm going to subtract 8x from both sides. And I'm also going to add 18 to both sides. So I end up getting 4x equals negative 2. And I divide both sides by 4. Negative 2 divided by 4 is negative 1/2. I promise we're not always going to get negative 1/2 as our answer. It just happened to be a happy coincidence there. Again, we can check, all right, and make sure that it works out. So 2 times negative 1/2 minus 3 over 4 should equal 2 times negative 1/2 minus 5 over 6. So that's negative 1 minus 3 over 4, or negative 4 over 4, or negative 1. Then we get negative 1 minus 5 over 6. That's going to be negative 6 over 6, which is negative 1. So yes, indeed, x equals negative 1/2. Now, what happens if the equation you get is quadratic instead of linear? But with linear functions, we can only have potentially one solution, right? But with a quadratic, we should always have two solutions, okay? But what we need to think about are things called restrictions, okay? Excuse me. So what is a restriction? A restriction happens, whenever your your fraction has 0 in the denominator because you can't divide by 0. Okay, so a restriction happens, it's whatever value of x causes 0 to be in your denominator. All right, and we'll see some examples of that today. So if you look at this next problem, we're like, oh, I know how to solve that, no problem. But before we get started, let's talk about our restrictions. So if you look at your denominator here, notice there is an x in your denominator. What can x not equal? What's going to cause it to be 0 in this denominator? And you should be thinking, well, -3, since -3 plus +3 gets me 0. So that's our restriction. X cannot equal -3. So let's cross multiply. Let's do our steps. All right, so I'm going to have x plus 3 times x, and I'm going to have 7 times 4, 28. I'm going to distribute my x through to get x squared plus 3x equals 28. And back to quadratic unit, we got to get it set equal to 0. Let's subtract 28. Okay, and then let's factor this, all right, if it will factor, and I believe it will. So factors of -28 that add up to +3, that's going to be +7 and -4. So then we are going to take both of those factors and set them equal to 0. So x plus 7 equals 0, x minus 4 equals 0. We're going to subtract 7 to x equals -7. We're going to add 4 to get x equals +4. All right, and that's none of our restrictions, so there's our two solutions. Okay, next one. Feel free to try it on your own if you feel ready. So I'm going to multiply x times 4 minus x to get 4x minus x squared. I'm going to multiply 5 times 2x plus 1 to get 10x plus 5. I want to get everything on the same side, and I want to make sure my x squared is positive. So I'm going to add x squared to both sides, and I'm going to subtract 4x from both sides. One thing that I forgot to mention before I got started was what can x not equal? So if you look over here, what value of x is going to cause this to go to 0? And that one takes a moment to think about, but you could always set this equal to 0 to figure it out. And you should be thinking -1/2. All right, so x can equal -1/2. And then for this one, 4, since 4 minus 4 is 0. So we factor x plus 5, x plus 1 will do it for us. And we set both of those factors equal to 0, and we get x equals -5 and x equals -1, which are neither of our restrictions. Okay, so let's look at the rest of the notes here. Now, this problem is a little bit different, right? You have two fractions equal to one fraction. We can't set it up and do cross multiplication yet, all right, unless we make these two fractions into one fraction. All right, so 2 over 5 plus 2 over 3, my LCD is 15. So I multiply my first fraction by 3 over 3 and my second fraction by 5 over 5. Okay, that's going to get me 6 over 15 plus 10 over 15. Okay, then I add them together to get 16 over 15. So now I have 16 over 15 equals x over 15. And now I could cross multiply because I have one fraction equal to one fraction. You also might think, isn't my answer just 16? And you'd be correct. All right, there's no other number that x could be to make 16/15 equal to something over 15. So x equals 16. All right, now you don't have to do it proportion method every time. You can actually do it another method. So I'm going to show you proportion method one more time, and then I'm going to show you the LCD method, which I personally prefer. All right, so again, for proportion method, you have to get these two fractions equal to one fraction. So let's do some side work here. So we've got 2 over x plus 5 over 3. My LCD is going to be 3x. So I'm going to multiply my first fraction by 3 over 3 and my second fraction by x over x. So that's going to get me 6 over 3x plus 5x over 3x. Put it together, you get 6 plus 5x over 3x. Okay, now we know that this one fraction is the same as these two fractions. So I can take this one fraction and set it equal to the other side, 7 over x. Before I forget, my restrictions, what can x not equal? Well, what's going to make my denominator 0? When x equals 0. So that's what x cannot equal. All right, so let's multiply through here, cross multiply. So I've got x times 6 plus 5x. That's going to get me 6x plus 5x squared. All right, on the other side, I've got 7 times 3x, which gets me 21x. All right, let's get everything on the same side by subtracting 21x from both sides. And then when we do that, we get 5x squared minus 15x equals 0. Factoring for this, very simple. We can take out a GCF of 5x, and we're left with x minus 3 equals 0. So that means 5x equals 0 and x minus 3 equals 0. But when we divide by 5 here, we get x equals 0, and that's a restriction. That is extraneous. It's not a solution, okay? But x equals 3, that's good to go. Now, I'm going to show you the same problem. Oh, sorry. That's okay. I'm going to show you the same problem, and we're going to use method 2, which is our LCD method. Okay, and then I'll go back and show you those other problems. So here's this the same problem, but we're going to do it in a different way. So the LCD method, to do it, you find the LCD of all 3 of your fractions. Okay, so we want to make these guys the same thing. So the LCD of those 3 things is just 3x. Okay. All right. So we know the first fraction gets multiplied by 3 over 3 to get 6 over 3x. The second fraction needs to be multiplied by x over x to get 5x over 3x. And the final fraction needs to be multiplied by 3 over 3 to get 21 over 3x. Now that we've gotten all 3 of these to be the same, we don't need to worry about it anymore, and we just have to solve the equation up top. So we've got 6 plus 5x equals 21. We're going to subtract 6 from both sides, and then we're going to divide by 5. And we get x equals 3. Notice I didn't even have to worry about my restriction there. Okay, you're more than welcome to try this problem, whether you want to do proportion method or LCD method. I'm going to do LCD method again for you real quick. So you've got x, 4, and 8. So my LCD is going to be 8x. My first fraction gets multiplied by 8 over 8 to get me 8 over 8x. My second fraction gets multiplied by 2x. So that's going to give me 6x over 8x. And my final fraction gets multiplied by x to get 7x over 8x. Reminder, x cannot equal 0 because that would make 0 in my denominator. So we solve my top equation. 8 plus 6x equals 7x. We're going to subtract 6x from both sides, and we get x equals 8. Okay, I have one final problem here that wasn't on the notes, but I think it's good for us to go over. So let's talk about the LCD of this one. All right, and again, you're more than welcome to do proportion method. I just prefer LCD. I think it's a little bit quicker and easier. So my LCD for this one, well, it has to include x minus 2. It has to include an x, and it also has to include 3. So 3x times x minus 2 is our LCD. The first fraction needs to be multiplied by 3x over 3x. So that gets me 9x over my LCD. My second fraction needs to be multiplied by both the 3 and the x minus 2. So I would do 4 times 3 first to get 12, and then I would multiply by that x minus 2. Also, the bottom would need to be multiplied too. It's not just the top. So I would end up getting for my second fraction 12x minus 24 over the LCD. My final fraction needs to be multiplied by x minus 2 over x minus 2. So I end up just getting x minus 2 over here. Remember your restrictions. X cannot equal 2, and it can also not equal 0. So let's solve the problem here. We're going to add up our x's over here to get 21x minus 24 equals x minus 2. I would subtract x from both sides to get 20x. I would add 24 to both sides to get 22. And then I would divide both sides by 20 and reduce the fraction to get 11/10. And that is how you solve rational equations.